So you're getting ready to see the lesson for the second day of section 1.6. This will be our last day of 1.6, and this is solving equations that have radicals in them, whereas the previous day, 1.6.1, was solving higher order equations by factoring. So basically, 1.6 goes into various powers, where 1.5 last week was all quadratics. 1.6.1 was again cubic, quartic, and beyond, whereas square roots are 1/2 powers. So we're just working with different exponents. The steps are over to the left. If you like to have steps to go by, to be concrete sequential. If you end up finding this lesson challenging, and some of you may, there's going to be a few types of problems that if you're coming straight from Algebra 2, you haven't seen exactly like this. You've solved these equations, and when I get to them, I'll mention. But if you're coming from Algebra 3, you've seen all of this, and I imagine you have if you're coming from pre-calculus. So the first thing we'll need to do is isolate the radical, and then we'll raise to the reciprocal power. I'll talk about that more, but since a radical has the same power, or is a 1/2 exponent, we'll square that, and then we'll solve whatever equation we have remaining. This could be a really easy step, like one step, or it could be a quadratic equation where we've got to factor and use the formula. And we'll have to check for extraneous solutions. So whenever you raise both sides to a power, you can get some solutions that aren't actually solutions, and they're called extraneous. So we'll have to check for those, and we'll do that as we go. So starting with this first one, if we isolate the radical, we'll add 4 to both sides, and then divide by 3. And here's where I want to make sure I'm clear, especially this first time. In order to remove the radical, we want to raise to the reciprocal power. So you should have had somewhere along the way that a square root is the same thing as a 1/2 power. Specifically, the index is 2, the exponent is a 1, and that's where the 1 and the 2 would come from. So to go a little further, if you had x squared, take the cube root, that would be the same thing as x to the 2/3 power. So radicals and powers can be interchanged as far as how they're written. So I wanted to make sure that you remember that so that it makes sense why we are going to square both sides. So if we square both sides, squaring a square root means the radical and the square would cancel out. Because if you raise something to the 1/2 power and then square it, power to a power you multiply, 1/2 times 2 is 1, so they cancel out. So again, squaring a square root, those are inverse operations that would cancel out the radical, and we would have x isolated. So then we need to square the right side. Please do not use a decimal. If this is so easy to do, you simply square the numerator, square the denominator, reduce if possible, but this one doesn't. So we'd have 16/9. We need to check for extraneous whenever you raise both sides to an even power. So later, if we're raising both sides to the 4th power or 6th power, I'll talk more about that later, we'll have to check for extraneous. So whenever you're raising both sides to, I'll make a little note here, to an even power, so check for extraneous. So we squared, we raised it to the 2nd power. So if we plugged in, and you can just do this in your head, you don't have to show work, but I guarantee you there'll be a problem on the test where there's an extraneous solution and you'll have to throw it out. If you don't catch it, you'll miss quite a few points off of that problem. But if we were to plug the solution in, the square root of 16/9 is 4/3. The 3's would cancel out, and we would have 4 minus 4, which equals 0, so that's okay. So that's our checking for extraneous. You can do that in your head, you can use it on a calculator, but as long as it fits the original equation, it's good to go. Continuing to some that have a little bit more going on, or a lot of it more going on. So first step is still the same, isolate the radical. So we're going to subtract 2 from both sides. Now that the radical is isolated, if you recall, raise to a power. So we're going to square both sides. So square and square. I'm going to make my marker a little smaller. So on the left side, we'll have remaining only 2x minus 1. On the right side, we're squaring this binomial. I'm going to use the shortcut that I showed you in a previous lesson. So you could go out to the side. You could do this all semester if you like. X minus 2 squared, there's a definition. You could FOIL it. I'm not going to write this every time, but you could FOIL it and get what I'm getting ready to get. But the shortcut is square the first term, double the x in the 2, and square the second term. If you FOILed it, you get the same thing. You just would have a couple more steps. So now this is quadratic. So remember the next step is solve the resulting equation. While on the last problem, the equation was pretty simple. I mean, there wasn't anything to do because it was just an x. On this one, it's quadratic. So we did this last week though. So get a 0. I'm going to subtract 2x and add 1. And I'm going to stop here and double check that I recopied everything correctly, squared correctly, that binomial, and gotten a 0 correctly. So that looks good. So at this point, since I'm not assessing quadratics here, if this was on a test and it said show all work, you can decide if you want to factor or use the formula, if it even factors. Now you couldn't graph it and find the solutions, the x-intercepts, and tell me that the answers are 3 and 5 or whatever they are. If it says show all work, you have to show me that you know how to solve this. But I'm not testing quadratics here. When you have the quadratic section on test 1, the directions will be solve using the formula, solve by factoring, solve algebraically. You will have to show me on the test somewhere that you can use all 3 methods. Here it would be up to you. This factors, so I'm going to factor what adds to get -6 and multiplies to get 5. I was a little slow there, sorry. So -5 minus 1 adds to get -6 and multiplies to get +5. So our solutions, if we set each factor to equal to 0, we get 5 and 1. So that's our solution so far. We need to check for extraneous though. And I'm going to need to go back to the original to do that. 2x minus 1 plus 2 equals x. And I'm going to copy that down here. Okay, so if we plug in 5, we would get what? 10 minus 1, we have 9. So we'd have 3 plus 2 is 5. That's good. For the other solution, if we plug in 1, well, let me do it over here. If we plug in 1, we would have 2 minus 1 is 1. The square root of 1 is 1. That's not true. So 1 is out. And I hope I haven't made a mistake. I don't remember these answers from the last time I worked them. I'm going to go back and double check. So if I did, I'm going to fix it in this video. I'm not starting over. So now I'm checking my extraneous work. Yeah, so it holds that 5 is the only solution. 1 was originally a solution, but it was extraneous, so it's out. We have 1 or 2 more. They just get progressively a little more difficult or different. With this one, looks very different from the previous one because we have two radicals. Sorry about all the movement. I'm gonna get rid of those gray marks too. So what you would need to note is this one has two radicals. Well, that means we can't isolate the radical. We can't put the radical on one side, well, it already is, and combine them. If you remember from Algebra 1, I guess, you can only add and subtract radicals if what is underneath is exactly the same. So like these, you could add together and say, well, that's 9, radical 3a. But the radicand, that's the 3a, has to be identical in order to combine radicals. It's kind of like combining like terms. So we don't have that. One has 3x plus 2, the other just has x. So what we're going to do is put them on opposite sides. So I'm adding one to the other side. Now we will square both sides. On the left side, the radical and the square cancel out, and we have remaining only what was underneath. On the right side, that 2 right here is a whole number. So that 2 has to get squared. So we're going to have a whole number of 4. And then the square root of x squared cancels out, and we just have x. So the right side is 4x. I will tell you a common mistake is to forget to square that, because on so many of the other problems, everything was under the radical. So out of habit, students just recopy what they saw on the previous line. So like they take this 3x plus 2 and recopy it, which is fine. They would take this and recopy it and say, well, it's 2x. But in this case, since we had a coefficient or a number in front of the radical, I don't know if that's technically called a coefficient in that case, but we had a whole number, it actually gets squared. So solving this equation, we have an easier go of it than last time. We'll subtract 3x from both sides and we get that x equals 2. So that's our solution so far. Checking for extraneous, if we plug in 2, we would have the square root of 8 minus 2 radical 2 equals 0. And I know that this is a true statement. Some of you might also. So there's a couple ways you could do this to check to see if those do subtract to equal 0. You could convert the square root of 8 to a decimal. I'm trying to write the word decimal. And you could convert 2 radical 2 to a decimal. And if you get the same decimal, then 1 minus the other would equal 0. A more sophisticated way, and the way I would prefer, is if you recognize that the square root of 8 simplify is 4 radical 2 or 2 radical 2. So 2 radical 2 minus itself equals 0. Either way you go about it, whether you know how it simplifies or you convert to decimals, it does hold that 2 is the only solution. It's not extraneous. By the way, you could have 2 solutions and they both end up being extraneous, so you would say no solution. So you could have a few different scenarios. Here we had 1 solution, it was fine. Previous problem, we had 2 solutions, 1 solutions, 1 we had to throw out. So 1 was extraneous, we were left with 1 solution. You could have 2 solutions and they're both okay. You could have 2 solutions and they're both extraneous. So just different scenarios. There's really no way to look at the problem initially and project what's going to happen. You just have to solve the problem. We have it one more, I think. This will be the last one. Now I think this is kind of a repeat of the previous one. So the radical is already isolated. We would square both sides. So I'm going to squeeze that in there. I'm having to walk over to my desk to make sure I'm choosing the same colors because the colors are jacked up on the overhead. So squaring both sides, I'm again using that shortcut. So first term squared, x and 4 doubled, and then 4 squared. And on the right side, the radical and the yellow square, or the yellow 2 exponent cancel out. This is quadratic. We want to get a 0, so I'm going to subtract 2x, keeping this in descending order. And then you can factor or use the formula. I'm gonna factor -8 minus 2 adds to get -10 and multiplies to get +16. By the way, if I'm losing you in here, that means that you didn't learn last week's lesson very well. You would have had this in Algebra 1 and Algebra 2. And if you took Algebra 3 or pre-calculus, you would have had it there also. So this would be at least your third time seeing it. For some of you, it's your fourth. So that's why I'm not spending a lot of time going through the X method and stuff like that. If you're struggling on this, go back and look at the old lessons, try all of those problems, and or contact me and we can talk about quadratics together. So we were here after squaring both sides. We realized it was quadratic. We got a 0. We decided to solve by factoring. So now I'll set the factors equal to 0 or pretend that I did and solve. So we would have x equals 8 and 2. Checking for extraneous. If we plug in 8, we have 8 minus 4 equals the square root of 16. Well, that's true because 4 equals 4. Plugging in 2, we have 2 minus 4 equals the square root of 4. That's -2 equals 2. That's not true. So that is extraneous. So the 2 is out because we didn't get a true statement when we plugged it back into the initial problem. So 8 is the only solution. I think this is the last one. This has 2 radicals again, so we can't isolate the radical. We still want to put 1 radical on the other side, so I'm going to move the one on the left. And we're still going to square both sides. So this right side is going to get a little messy. And if you know the shortcut, it ends up being very helpful here, in my opinion. So squaring the left, easy peasy. The radical and the exponent cancel. Squaring the right, I have a binomial. So I'm going to use that shortcut. I'm going to square the first term. I'm going to multiply the 1 and the radical together and double it. And I'm going to square the last term. I'm trying to be neat. So stop there and look at that. I took the 1, this 1, and squared it. 1 squared is 1. The middle term comes from taking that 1 and that radical and doubling it. So 1 times radical x plus 4, if we double it, is 2 radical x plus 4. And then the last term, we square this term if it is all under a radical. So when you square the last term, the radical falls away, and that's why we have only x plus 4. Make sure you practice these on the suggested practice. I think only people coming from Algebra 3 have seen this. I don't think anyone in Algebra 2 would have done a problem just like this. You would have solved radical equations. I'm almost certain you didn't do this. This would be new for you. And I'm not sure about pre-calculus. I know we did an Algebra 3, but it's been a year, so you would need to try them too. So look at what we have. We still have a radical equation. So go back to step 1, isolate the radical. So I'm going to move the 1, the x, and the 4 all at once. So the 1, the x, and the 4 are going. So 3x minus x is going to be 2x. So I just moved that, so I'll scratch it out. Moving the constants. If we subtract 1, we have 0. And if we subtract 4, we have -4. So I'm isolating the variable. I still haven't yet isolated it. We have this whole number 2 out front. It's being multiplied to the radical, So we're going to divide both sides, the whole side by 2. So on the left, 2x over 2 is x, 4 over 2 is 2. On the right, the 2's divide out, which was the whole point. So this is a lot of stuff. This is really healthy with algebraic skills, moving things around and isolating things. This has been a long problem and we're not done yet. So now we're squaring. So we will square both sides. For the 3rd or 4th time today, I'm going to use that shortcut. So first term squared, the product doubled, the -2 squared, and the right side squared eliminates the radical. We have a quadratic equation. So I'm going to get a 0 on the right side. I'm going to subtract x and subtract 4. So the constant's actually gone. So we haven't had this today. It's a quadratic equation, but it's not a trinomial, it's a binomial. So we're going to use GCF factoring. I don't know why this is going so far down when I hit that. I'm going to factor out an x. We have x minus 5. Set each factor equal to 0 and solve. So we get 0 and 5. But wait, there's more. We need to check for extraneous. So we got 0 and 5. I don't even remember what the previous problem looked like. I might just kind of talk through it. I think I'm going to. If we plug in 0, so up here, I plug in a 0, we're going to get the square root of 1, because 3 times 0 is 0, plus 1 is 1, minus the square root of 4, and we want that to equal 1. Well, that doesn't work, does it? The square root of 1 is 1, minus 2 does not equal 1. So that was if we plugged in 0. So I'm going to scroll down. 0 is out. Let's go back and do 5. We plug in 5. So I'm plugging in 5. 3 times 5 is 15, plus 1 is 16. 5 plus 4 is 9. The square root of 16 is 4, minus 3 does equal 1. So 5 is okay. So 5 would be our only solution. You don't have to make a note of this on the test. If you marked out 0, I would know that 5 is the only solution. So there's a lot of stuff there. You're solving a radical equation, but you actually ended up solving it twice, sort of. You had to square both sides twice. You were isolating a variable. That was a good little bit of work. And you ended up solving a quadratic using GCF factoring. I think that was the last one, unless I'm doing 2 of these. That was the last one. So here's your assignment. We're still in section 1.6, page 178. I suggest you try the odds. And I suggest everyone try those harder ones towards the end. I'm not exactly sure of the problem numbers, but I hope you're not skipping problems yet and still doing all of these. But at least try the most complicated ones. You can see where if you were in my Algebra 3, I had you guys do this assignment. You all had this actual presentation. And those 2 problems at the bottom where I've X'd out, you all did those too. So there's the suggested practice. Here are the solutions. The no solutions are coming from whatever solutions were originally there end up being extraneous. So apparently on 25, 9 was the only solution initially found, and it was extraneous. 27 maybe had 1 or 2 solutions. Whatever you have, once you test them, you realize they're extraneous. So that's why we have 25 and 27 being no solution. Please let me know if you have questions. I can help you on the phone via email, or you can join my Zoom at any time, and I can help you at the Smartboard. I sent out a video. I'm not sure what day I posted it under, probably today, of our first test. Our first test is going to be when we return in person. You guys come back October 20th, I believe. Yeah, I think you guys come back the 20th. We'll review for 3 days and your test will be October 23rd.